All right, welcome everyone. So, we all want to get to be more effective Scala developers, I guess. But who's new to Scala? Who hasn't done any Scala or very little Scala? Okay, and who's been doing that for maybe a couple of years, 2 or 3 years? Okay, good. Then I guess this is going to be interesting for most of you. So just a few words about me. I'm the co-founder of Triplequote. Maybe you've been at the Graal talk before. That's the company that Thomas couldn't remember is Triplequote, and we're doing the Hydra compiler. So Hydra is a commercial compiler for Scala, and what it does, it allows you to compile Scala faster. And how does it do that? Well, it compiles in parallel, so it uses all the cores that you have available in modern hardware. That's about the plug about Triplequote. Other things about me, I've been doing Scala for quite a long time now, and I contributed to several open source projects, among which Lagom, the Playframework, and the Scala compiler itself. So, the golden rule, I would say, for Scala, and throughout this whole talk, is that we want to try to keep things simple. And I think you should do this even more in Scala, considering the full opportunities that the language gives you to actually make things more complex than they need to be. So, doing Scala, I often feel like that guy, I'm a superhero. You know, I create this beautiful code, at least it's beautiful to me. It does tons of things in, you know, maybe 1 or 2 lines of code, because there are lots of other things happening behind the hood. But the thing is that despite you feel like that guy, there are always guys feeling like the other one in, you know, in the back, blurred, that really doesn't get what you're doing. It was forced to be wearing this, you know, superhero costume, but he actually doesn't have a clue of what you're doing, and it doesn't have a clue about what the code does. So, it's not because in Scala you can do a lot of things. It's not because Scala offers you all these tiny, well, all these shiny tools that you should use all of them together at the same time in every project. Otherwise, you end up like this guy, which is definitely been me several times in my life. I'll just give you, a few seconds to read through it. Hopefully you can all relate to this comic. You write code, it looks beautiful, then you just don't touch it for a while, you go back to it, it's like, well, I don't really have a clue what this code is doing. So this talk is going to be opinionated. It's a lot of opinions. It's going to be my opinions. I'm sure that not everyone will agree with my opinions, which is great, because it means we'll have a lot to talk at the end or after the talk. So you're very, I would encourage you to ask as many questions at the end or after as you can and want. I'm very apt to discuss all of these things. And I'll also see whether you find that some of the things I say, they actually make sense to you as well. So the agenda, we're going to start with some stylistic decisions that you can make about how you write your code. That sometimes they actually tend to be not just style, but also have a huge influence in bugs that you may or may not catch at compilation. So we'll see what those are. And then I'll give a few of my mantras, what I think are, well, things that in Scala should really be part of you. You shouldn't even think about these things. You should have it in you. They're really part of the philosophy of Scala and how you should be writing Scala code. And then we'll have a short plaque on collections and implicits, on things that you should maybe do one way instead of another way. So do's and don'ts on collections and implicits. So style. Let's start by saying, maybe for the people that are just approaching Scala, they're new to Scala, I would say you should really try to learn the Scala way of doing things. So try not to bring too much from other languages, which may or may not make sense for Scala, depending on your background. So actually spend the time to look into the Scala guide available online and try to stick to those conventions because, well, probably the people you'll be interacting with either at work or on the community, they will probably follow those same conventions. So it's about trying to have a similar style and avoiding confusion and unexpected comments maybe on your pull request. And the other aspect about style is also about having a common style, enforcing it. So use some automatic tool for enforcing that, whether it's Scala style or Scala FMT, whatever tool you prefer. But the point is, try to avoid spending hours or countless time over discussing style, which really doesn't matter at the end. Just agree on something. Have some automatic way for checking the style and then move on. You don't have to discuss that for every pull request. Abstract members. So what do you think about this definition? Would you, we defined field, edge, it's an abstract field, and we made it a val. Is the fact that it's a val or a def making any difference?
Yes. The val is evaluated when you instantiate that, so it's a problem when you use object orientation in Scala. I actually don't know why that's not a bug, and the compiler doesn't tell you this is a bug.
Okay.
I have a problem with this code, and yeah, I was wondering why this is not considered a bug.
So this is just an abstract definition, but basically what you're enforcing by doing this is that the implementers of this abstract member, they need to define it as a val. They cannot override this definition and make it a def. So you're basically saying that that field is state, is not computation. You're making a very strong case about it, and you're basically disallowing anyone else from overriding with computation. So if you don't have a really good reason for doing that, then you shouldn't do it. Then always use a def. As I said, it's going to be opinionated. So when in doubt or where you don't know, use a def so that you're actually giving the liberty to implementers to decide whether that should be a def or a val. Yes, so when is a good idea to use val instead of def? It depends on what the val is supposed to hold. Let's say that it's supposed to hold some costly implementation that maybe some other methods in the same thread provide some implementation calling on this abstract field. In that case, if you expect that that abstract field is going to be costly to compute, like accessing the database, maybe you don't want to do that for every call, then make it a field so that you're actually forcing that into the implementers. True, true. You're taking a decision. As the API designer, you take a decision. You have that liberty. You can take a decision, a strong decision for everyone. But if you don't have a good reason for doing that, don't do it. Make it a def. That's really the point of this slide. If you don't do it, if you don't know, just make it a def and move on. You don't have to think about it. It's an easy decision. So another one is override, which in Scala, it's mandatory if you override on a concrete member, but it's actually optional if you're overriding an abstract member. And I'm going to tell you, always use override unless you have a good reason not to. And there are possibly some reasons where you don't want to use it. It goes back to how linearization works and how when you mix several traits, how things may work and how you may want to allow some mixing instead of others. But more often, I would say 99% of the case, you're not thinking about that. Okay, so let's take that away. So why wouldn't you put override? I don't know. I would always put it because this way, if someone goes and changes the superclass, it changed the methods that I'm overriding, the compiler will tell me, hey, this method is not overriding anything. So I have a compile time error about something that has changed. That's one reason. Second one, it's when I'm reviewing the code, it actually helps me understanding if a method is being overriding something or not. Another very easy one is don't leak types, especially try to have explicit types for all your public members. So in this case, if we look at the apply method, what is the type that is being inferred by the compiler? It's going to be the standard logger type. So you're actually leaking this type, this standard logger type that you may be meant to be sort of an internal, an implementation detail. So be explicit in this case and just say this is a logger, right? And even you could go even a step further and actually make the standard logger a private class so that actually there is no way for that to leak, right? Because the compiler would tell you you're actually leaking a type that is private and that's not okay. And that's basically the point I was making about making it private. It's here. Use the access qualifier that you the access qualifiers that you have in Scala to clarify your code. When I'm reviewing a pull request, knowing if something is accessed by everyone or if something is meant to be accessed from everyone outside or not, yeah, it actually makes a difference. I want to know what is the API and what is actually implementation detail. So because in Scala the default is that everything is public where you don't specify it, they use the access modifiers to actually specify whether something is private, protected, and so on. And in fact, you should be aware that Scala has much richer access modifiers than, say, Java or C# or other languages you may be used to. In fact, in Scala, access modifiers can be augmented with qualifiers. So if you look at the example at the table Java in Scala, how you could basically express the same semantic. If you look at package private in Java and how we express it in Scala, that's using a qualifier. So it's private, and then it qualifies by saying it's private to this package. So it means that only classes within that package can have access to, let's say, the member that has that visibility. And in fact, there are a number of interesting things that access modifiers with qualifiers gives you in Scala. For instance, did you know that private members of companions can access each other's? So if you, let's say you have a class where you have a constant, you can actually put it in the companion object, make it private, and the class can still access that member. You don't have to make it public. And by doing that, you're actually getting some performance benefits because it's a constant, it's going to be inlined. So whatever the field contains, it will not be allocated several times for the many instances of the classes that you'll be creating. So in Scala, being a more functional language, we tend to write recursive code, right? At least I do tend to do that quite often. And one thing you should make sure is that when you write recursive code, you're not going to blow up the stack. So in order to do that, you need to make sure that your implementation is stay recursive. So meaning that the last call in your implementation, it's always either the recursive call to the method or a value. That's the only place where a recursion is allowed is as the last expression in the method implementation. And sometimes it may be hard to understand whether something is stay recursive, or maybe you understand it and someone else comes along and then it changes the implementation and suddenly it's no longer stay recursive. So in Scala, what you can do is actually using an annotation. You use Scala annotation tailrec, and then it will be the compiler job to tell you if the implementation is not tail recursive. There will be a compiler error, so at compile time, you will know if the implementation was changed in a way that is not tail recursive anymore. And last thing about style, I really like string interpolation. And I really don't see any reason for writing a toString like in the first way. I would rather use string interpolation because it makes it easier to read on the one side. But it also makes it easier to avoid errors because these real and IAM variables, they're actually checked at compile time. If I'm going to refactor the name of the field real to something else, I will get a compilation error again. So the only reason why you may not use string interpolation is for performance reasons, because behind the scene is going to create a string buffer. Basically, it's going to concatenate these different elements. So if you have those kind of reasons, fine. But again, I would expect that most times you don't have that kind of needs, maybe especially for a toString. And so using string interpolation makes a lot of sense because it makes your code more readable and just nicer. Good. Let's go with mantras. First, use the rep. You have this fantastic tool where you can just, try things out very quickly. If you're using SBT, just type console. You get into the Scala rep, and for you, all all the jars that you define in the class part of the project that you're working on, they're going to be available in, in the rep. So you can actually experiment and explore the API of those dependencies that you have in the project. It's really useful. You want fast Scala compilation? Other than using our compiler? Then what you should do is really try hard to stay in a JVM that is warm, because that's going to deliver up to 2x speed up just by having a warm JVM. And I'm telling this because I've seen people, like experienced Scala developers, like they use SBT, and every time they wanted to compile, they would go with SBT compile. So what happens there is that basically you will never have a warm JVM to compile. Because if you type SBT and you enter the interactive shell, and then you compile only when you're inside the interactive shell, the compiler, it's going to be, well, you'll profit from hotspot, and so you'll get the JVM that does the compilation to warm up, and that will reflect in your compilation time. So you will actually have up to 2x compile boost in compile time just by staying inside SBT instead of compiling from outside. And for Maven it's the same, or Gradle, or the other build tools. There is this Zinc server. So you can just basically, there is documentation for spawning a Zinc server so that when you compile, you're actually sending sort of a compilation event to the server, and the server is going to be kept on the background so that as you compile, it will warm up and you will benefit from having a warm JVM. These is a really simple things to make you way more productive. Scala is an expression-oriented language. So what's the difference between expression and statements? So statements basically returns a unit. They return no value. While expressions, they always return a value. So what is the fundamental change when you have an expression-oriented language? Well, you can compose things together. You can chain them because you always have a value on which you can do something, right? So you can compose these things together, which is something you cannot do with a statement-oriented language like Java or an imperative language just in general. So yes, my reason is really that it makes your code, an expression-oriented language makes your code shorter, simpler, and composable. And that's really, that has huge implications. So let's just have an implementation. What I'm doing is I'm just trying to prepare some HTTP page, and I can get some exception, and based on that, I will have to return a different kind of page. And I'm writing this in a very imperative way, assuming that I'm not using Scala, but let's say this is sort of a Java-like implementation, how I would do it in Scala, but let's say I'm using Java. So I'm doing it this way, so I need to create a var, because try-catch is a statement. It doesn't return a value, right? So I need some way to sort of hold the state that is going to be side-effected by the try and the catch. Well, but since Scala is an expression-oriented language, and considering what I told you, so we can make things shorter and simpler, let's refactor that. And this is how it would look, actually, in Scala. We don't need this extra variable. Try-catch is an expression, so it returns a value, so we don't need to hold any state outside of it. We just return the value, right? But I just told you that try-catch is an expression, so what's interesting is that if you look at the catch, that's actually a partial function on the right-hand side of the catch, right? So we can actually break that down. So we can break it down. Let's say that we have some complex logic that we want to reuse across different methods. So we extract this logic and we create two methods, this timeout catch and no page catch. And now we want to reuse those in the initial implementation. How do we do it? Well, we compose, right? It's really the beauty. We get expressions, and so we can compose them together. And we can reuse. We don't have to repeat ourselves. Return. You should really not use return in Scala. There is really not good reason to use a return. And actually, it's so bad that it may even have performance implication that you don't expect, the fact that you use a return. So let's have a look at this code. we're just processing files, and then we're basically giving the opportunity from the outside, from a different thread, to sort of stop this computation. This is what this is interrupted variable is used for. Okay, and then if basically someone tells me I should stop, I will just return. How is this compiled? Who knows? So this is how it's compiled. So the return, it's actually translated into an exception. So it will throw an exception, and it will catch that exception. So that, basically, you terminated the computation. It does what you expected, to some extent, actually, but it does so with throwing an exception. You don't have to do it this way, right? You can just, have a filter instead of having a return and just stopping the computation in, I would say, a very normal way. So really just avoid using return, because it's not just not idiomatic in Scala, but it might translate to code that you really don't expect to see. And the other thing is that if you look at the implementation, actually at the initial one, well, would you expect that the logger so considering, no, okay, well, now I wanted to make another point, but let's go on. Another simple thing in Scala, don't use null. Honestly, the only time when I wonder about null in Scala nowadays is when I interact with Java libraries. And then it's always a hell. I never know what I have to do. I always have to go and check the implementation. Is this returning null or not, this method call? And then if it does, then I have to wrap it inside an option, even though I'm not telling you this right away. So null is really a disease. Like null checks will spread because you always have to check whether something is null or not, and all the callers have to do that. So it's really a domino effect. Null pointer exception will still happen, besides the fact that you try to avoid them with these null checks. But they always end up happening because you always forget some place where you should be checking if something is null or not. And the assertions won't really help, because if you get a null pointer in production, the assertion didn't really help. I mean, you just get a different kind of exception maybe, but it's just still as bad as having a null pointer. So instead in Scala, if something is null, just use option instead, and basically make that information part of the signature. Express the fact that something may or may not have a value. And it's really about being type safe and about documenting what you're doing. If I'm looking at a pull request, I see a method with a signature that takes an option, it's really clear there that it might or might not have a value that I'm passing to that method. If that value actually could be passed as a null, I have no clue about it. So here is an example of how using option, so on the one side it's documentation, so it's part of the signature, and on the other side, the code actually it's pretty neat. I don't have any null check, I don't have, it just flows. I can just read it, it's clear. If I have a username and I have a password, if I can authenticate the user with a given password, then I just give the privilege for the user and I move on. So, but on the other side, I would also say don't overuse option. Why? Well, because when you use an option, you're also forcing the caller to handle that option, right? It will always have to say, well, if I have the value, I will execute this logic. If I don't have this, the value, I will execute some other logic, and so on. And there are cases where actually having a null object is a much better fit. So a null object makes it transparent for the caller, what you're going to return. Whether something that is supposed to render, a proper page with an authenticated user, or maybe something that is supposed to produce something like a 404. For the caller, it's completely transparent because he knows all he has to call maybe is the render method. So as long as he can call the render method, it doesn't matter to him what kind of instance he got. So again, I would say options are good, but abusing them tends to actually create code that is not so easy to maintain or so easy to read. And so there are situations where you should actually be thinking about using a null object. Exceptions and control flow. Again, I think this is something that at least I've seen a lot when I was doing Java, and I don't see as much when I do Scala, but it still happens from time to time. You know, when you have an error that is an application error, you should really not be throwing an exception, but you should really make that information part of the types. So you can use either, you can use validation maybe from you know, these functional libraries like Scala IDE or CATS, and make that part of the contract of the method. So the method is expected to either return a value or maybe a set of errors. And those are all expected and valid return values. Then there are exceptions, are for exceptional cases, are for things that are not expected application errors, but things that we cannot recover from. So in that case, it's absolutely fine to throw an exception. But I do not expect the caller to react on that. And of course, there are frameworks, maybe like Akka, that expect you to throw exception because that's how they were designed. So of course, in that case, it's fine to throw exception. But I would say in your application code, if you're now forced into doing things because of a different framework, don't do it. Make sure that you express the error as part of your signature. Immutable. Let's always stay immutable. 3 reasons why it matters. I don't know what are yours, but those are mine. Definitely simplified reasoning. Why? Because I can just use the substitute principle. So if I have, you know, some code that does something, but it returns an immutable value, I can just replace the computation from the immutable value and keep reasoning about my code. There is no side effect that I need to track in my head because that's not what an immutable object is, right? So it definitely simplifies reasoning. Another thing is that it allows co- and contravariance. So variance, it's complicated, but if we think about Java, well, arrays in Java. Okay, so I have a string of array, and then I have an array of objects. And I assign to this array of objects the array of strings. That's okay, because in Java, arrays are covariant. So it means that if A is a subtype of, well, in this case, if string is a subtype of object, then an array of string is a subtype of an array of object. And that's okay, so I can do that. But then if I can do this, since an array is mutable, then I can actually put something into the array of object. Let's say I can put an integer, right? Well, if I put an integer in an array of object, which is actually pointed to an array of string, that's definitely going to create some problem at runtime. And so this is the kind of problems that you can get in Java. This is bad. If a type check language allows you something like that, it's bad, because it's basically not protecting you from something that should actually be an error at compile time. There are reasons why it was done this way. I'm not going to get into it. But the point here is really that mutability and variance means trouble. If you have immutability, you can have co- and contravariance. So if you look at the Scala immutable collections, that's why you can have covariant collection. You can have covariant immutable collections. While if you look at the mutable Scala collection, they're all invariant. And other nice things that immutability gives you is actually a way to define a correct equals and hash code. In fact, if you try to define equals and hash code on something that is not immutable, then that's definitely a bad implementation. You cannot. You cannot respect the contract of equals and hash code if something is mutable. And of course, getting back to my initial point, it also simplifies reasoning about concurrency, because immutable objects are thread safe by design. So with that, I don't want to say that you should never use mutability, but you should make an effort to contain mutation to really small scopes. That means usually like maybe inside a method implementation, and really do all you can to return immutable values as part of your API or your method. So mutation is perfectly fine inside an implementation, but try to avoid passing mutable objects to the outer world. Good. Let's go to the collection side. So if you add a look at the collection hierarchy, it's pretty complex. And I mean, this is only sort of the generic hierarchy, but then if you look at the immutable and mutable one, it gets very complex. There are lots of class and traits. But at the eye level, you should sort of know why is it like this. So how is a traversable different from an iterable? Who knows? So a traversable gives you a for each method. So that means that you're not in control of the iteration. The iteration is made by the collection. While if you have an iterable, you can get an iterator, so you can be in control of the iteration. And then you have seek, set, and map, and behind those you have different, some other different implementation. But like, what's the difference between an index seek and a linear seek? And that's the moment where you need to start thinking about complexity. So if I want to access any element in my sequence in constant time, I better use an index seek. So if I'm thinking about maybe concrete collection in Scala, would I use an array or would I use a list for having constant time access to any element in my collection? I would definitely use the array. The list, on the other hand, is good if you're writing elements at the beginning. So if you're prepending elements to the list, in that case, you get constant time. It's a constant time operation. While with an array, that's actually a really bad operation because you need to copy, right? So the point here is that you should know the complexity of, the complexity characteristics of the collection classes so that you can make correct decision when picking one over the other. And if you really don't know how a collection is going to be used, whether it's going to be writing, let's say you need to use an immutable collection, but should that be a list? Should that be a vector? Should that be something else? And you don't really know how the collection will be used. Will the element be picked at the beginning, at the end, in the middle? So in case you don't know, just use a vector. Because it has basically good overall performances with all kind of operations. It's not the best for a specific operation, but overall is the best across all operations. So that would be the kind of the collection that I would use if I don't want to think too much about it. And the other thing is learn the API of the collection libraries. There are a ton of methods, and I cannot remember a time when I had to implement my own method for doing something with the collection. Usually, it either already exists, or I can just compose 2 method calls to do the job. While if I think about my times in Java, I would always have a util class where I would do things with collections because they were not part of it at the time. And now one question for you. If I'm writing this code, is the seek mutable or immutable? Of course, there is a trick. Just like this. Because let's take a step back. When we have a map or a set, and we don't have any import, what is the type there? Is it an immutable or mutable collection? It is an immutable collection in the case of map and set. But in the case of seek, like this, we don't know. It's the generic seek, okay? So if you want to make sure that that's going to be, so if you want to sort of have a contract on your caller and say, I want to receive only an immutable value, then what you should do is making the implicit, having an explicit import. So saying, I want to use the immutable seek, and then you're guaranteed that your seek will be immutable. And this could make a difference in the case that, you're in, maybe you're like doing things in parallel inside that seek. So potentially you're reading elements from different threads inside the seek. Whether it's mutable or not, it actually makes a difference on correctness. So it could make a difference. The good news about this is that actually this is going away in Scala 2.13, so the next release. They're finally going to make this as the default, so you will no longer need an import to immutable seek, But today, if until Scala 2.13, you do need the explicit import. Good. And now let's have a quick touch on implicits. The best recommendation I can give you with implicits is try hard to limit the scope of implicits. That's really the best tip I can give you. Make them so that they are not going to interact with all the code, maybe all the code in your source file, or maybe all the code in your project, but have a very specific place where you expect them to kick in. Okay, so the follow-up question would be, okay, but how do I do that? It's like, that sounds simple enough, but how can I do that? Well, you need to understand how implicit resolution works. You need to understand how the compiler is going to look for implicits. Because by understanding that, then you can understand where you should be placing your implicits so that you sort of reduce the scope of them. So the implicit resolution algorithm works in two ways. Well, in two steps. First, it looks for implicits in the current scope, in the local scope. So that means it looks for implicits that are available without a prefix. So maybe things that you defined yourself in the current scope, or maybe implicit that you imported, maybe because you have a dot underscore on something that defines implicits. So those are all going to be part of your local scope. If the compiler doesn't find an implicit for healing the expression that it's looking at in this scope, then it's actually going to move on and look into the implicit scope. And this is really where you should be placing your implicits. So the implicit scope, it might be not so simple when you look at it, but at the end it's actually really simple. You just look at the companion object of the types that you're trying to heal. Okay, so the compiler is going to say, okay, you have an expression from type, you have an expression of type A, but I actually expect a type B. So I'm going to look into the implicits, into the companion object of A and the companion object of B, and see if there is an implicit that can help me heal this expression. The compiler will do that for you without you having to import anything. It will just do that. It's part of his algorithm. Okay, so if instead of having implicits in the local scope, you manage to move them into the implicit scope, you are definitely narrowing it down where the applicability of your implicits. You're making it really specific. This implicit is only going to be used if I'm going to try to heal a type, something that is of type A to type B. And based on that, you can actually reason about when implicits are being used by the compiler. So, and another reason for putting the implicits in the implicit scope is that it allows the user to override whatever default you define. So this is particularly useful for libraries. If I'm adding an implicit in the current scope, it means no one can override that, right? Because I am deciding for everyone that that's the implicit that should be used. If I put it in the implicit scope, then I'm actually allowing my users to override that implicit by adding their own implicit, either explicitly or maybe as an import. So in this case, as you can see, we have the standard logger is an implicit, and where is it placed? It's in the companion object of logger. And as you can see, I don't have any import. So when I call logger.log, hello, the compiler is saying, well, I need to look for an implicit of type logger. There is no implicit in the current scope. So where am I going to look for that kind of implicit? I go into the implicit scope. And where is that implicit scope? Where I have logger, so I need to look into the companion object of logger. And, well, it turns out that there is a standard logger, so I'll find it, I'll use it, and inject it. And so the logger.log, the first logger.log call is going to use the standard logger. Now, say that, yes, I want to override that and actually use a remote logger. I can do that. If I had something defined in the scope, in the current scope, it would be a lot harder for the user to do that. And using, this is an example of using an implicit parameter. This is actually a really good thing. This is how implicit should be used in Scala, I would say. The one thing that you shouldn't do is using implicit views. So what is an implicit view? It's just something that translates a type to something else. So let's say here I have an implicit that translates any name into a station, right? So that I don't have to write this glue code myself. Well, actually, this is really bad. It's really bad because it makes it really hard for people to understand that something is happening underneath. There is no evidence that that's happening. Of course, the IDE is telling you something, but this is what makes Scala code, I think, really hard to understand, when too many of this sort of magic happens underneath. And so what should you do instead? Well, I'd say you should keep it simple. You should really not do that. If after 5,000, if you're doing this because you have 3, 5, 10 calls that are, you don't want to type new station of name, I think that's really bad to write an implicit just because you want to save a few keystrokes. I think you really need to feel the pain before you go into, sort of finding a more elaborate solution. I know, for instance, like Martin Odersky, the creator of the language, so he was saying that he had to sort of pass some implicit context 5,000 times before he decided that was too much. And so he actually went and created a feature in the language, in Dotta, that is called these implicit functions types. But it took him 5,000 repetition of the same thing before saying enough. And I think we should really get to that point to say, okay, it's enough. I see that I'm doing too much of the same. So maybe I should re-architect things in a way that actually don't make me write this boilerplate. And my expectation is that by then, when you realize that, the solution will probably not be an implicit view, because that's usually really bad, at least in your application code, but it will be something else. And implicit views, they have their, they can be okay, they can be used. I'm not saying that you should never, never, never use it. For instance, in test, I somehow feel those can be useful, but I really try to stay away from them in my application code, exactly because they make my code harder to reason about. Thank you all for the attention. And, well, it was an opinionated talk, so I hope you guys have a lot of questions. Yes?
I'm not completely sure I understood the return one. Return, you say now using return.
Oh, yes. Return.
Yeah,
This one.
yeah.
Okay, is it about the code?
No, I mean, is it, I mean, the kind of pattern of having a small function that say if something, then return A, otherwise return B.
Yes. So you're asking about having multiple return in an implementation. So in Java, so let's say that if you come from a background that is like Java, you need to use return. Why? Because you need to instruct the compiler that you actually want to return a value from this method. Because the language is not built around the fact that it's an expression-oriented language, right? Java is not expression-oriented. It's statements-oriented, if anything. While in Scala, everything is an expression. So that return is completely irrelevant. Like you really don't need it. It's just sort of noise. Idiomatic Scala, the last expression, of course, is the return value of an implementation. But that's just because any expression that is at the end is a return value. Any expression is a value. And that was one side of it. It was about it's not idiomatic in Scala. It's really not needed. And the other one, it was really about the fact that it can produce code that somehow you don't expect to see. And that's why I'm saying that you don't use return, but actually do it as you would do in Scala. So I would just use a filter condition on that for expression that would get me out of the loop. The added benefit of doing that is actually that the logger.debug would actually be executed, while in the case of the return, that is not executed. So I actually think it would be a much better way of expressing the intention of the code instead of using a return. So do you guys all, do you agree with everything I said? Hey, come on, there is no question, so you must be agreeing. Good.
Just one about the seek. You said when we don't specify it, then it's random.
No, so you see this? This is the hierarchy for, so in Scala there are actually, three hierarchies. There is like, for collection, there is the generic one, and there are two implementation, the immutable and immutable one, right? Even in the, this is also reflected in the import. You say scala.collection.immutable or scala.collection.mutable. So you have these two different implementations. When you, in your code up to now, when you write seek, you're actually referring to this seek in the scala.collection. So that means that as a user, I could pass you an immutable seek or a mutable seek, right? And so that means that that may be fine, but it really depends on you, on what you do in that implementation. Let's say that you're actually doing something that is multi-threaded, so you may have different threads reading on that on that sequence. Well, if the sequence is mutable and maybe gets changed behind your face, then you can actually get an explosion. So that's why I'm saying that since it's a good practice, since I think you appreciate the fact that map and set are immutable by default. If you appreciate that, then you probably want to have the explicit import as well for seek. It's just about knowing what you're gonna get instead of kind of leaving that to the user.
Okay, makes sense.
Before you said that as a collection you suggest to use vector.
Yes.
What is the difference with what's the default implementation of sec, because you can use directly the sec is good, or
Good. Not that. So I wanted to prove a point. So what you should do when you have questions like this, just do this. So by default, you get a list. So you don't get a vector. The reason, I can only speculate the reason why it's a list, is not a vector. It's because vector was introduced in Scala 2.9, and I think it could be surprising. Let's say that you have legacy code, you have code running that has been updated to Scala 2.10, then suddenly instead of returning a list, you get a vector. I think they didn't want to get into sort of that kind of trouble, or they didn't want to sort of put potential problems into applications that were upgrading from Scala 2.9 to later Scalas. But if it was me, I think it would be better to have a vector, because if you don't know what you want to get, then I think a vector is actually a better collection. But if you do know that, I tend to use lists quite a lot, because more often than not, what I implement tends to prepend elements. And so I actually appreciate that a list is constant time. It doesn't go, it duplicates all the elements that I'm prepending to. So to me, it's really about understanding and knowing the collections and knowing which one you should pick for the job that you have to do. And I think with that, we're running out of time. Okay, 2 minutes. So there is time for one more question. Maybe about Triplequote otherwise. Thank you.
So you mentioned the null problem and trying to wrap your types with in the options either try, future, depending on the need.
Right.
Something that can happen is then you may run with different type of aggregates. You can have options try either, and you need to work with them at the same time. Do you have recommendation how to combine all of those in a nice way?
Yeah, it's a really good question and point. So the thing is that in Scala you tend to have different containers. You end up, so the question is that you end up having things like futures and option and either and so on, try. And so how do you sort of treat all these different things uniformly so that your code doesn't become really bad to read? So in Scala at the moment, like in the Scala library itself or in the language itself, there is nothing that allows you that helps you with that. So what you could do is actually converting these things. So like if you're using a future, then you need to wrap the option into a future that's successful and so on. But there are other libraries, like there are, let's say, libraries existing like CATS or Scala Z that have abstractions that actually allows you to easily map one type to another without you having to write this glue code. You just sort of call a method and sort of makes it simpler to kind of work with these heterogeneous collections or types. But this is also something that I guess I'm lucky enough to be talking to Martin Odersky from time to time, and this is actually something I would like to improve, at least in Dotta. So I would like to have some sort of construct in Dotta, so that he has some language support for making it simpler to work with these different kind of types. Let's say in a for expression. So today I would say you need to look at these other libraries. But hopefully tomorrow this is something that will be easier in the language itself, because there will be, first-class support for these kind of things. But I don't think this is happening in Scala 2.13, so it's really probably going to be something for Scala 3.0. All right, thank you all. I think our time is over. And I'll be out if anyone has more questions.